Okay, hello everybody. I'm Rob Penzak, one of the leaders of Richmond Humanists and founder of Saved by Science. I want to thank the American Humanist Association for its Harvey LeBrun chapter grant, which allows us to give a very small honorarium to our speakers. I also want to thank UU for letting us use these facilities, and Paul Dolce, Abi Pandarangi, and Diane Woodruff for their help on the tech end of things. Thank you for troubleshooting today. All right, so climate change, this is something that our humanist group, when we first did a survey probably like a year and a half ago, thought was one of the topics that we really need to discuss. Climate change in the form of the abrupt anthropogenic global warming that an overwhelming portion of climate scientists have been warning us about for decades poses a catastrophic threat to civilization. We ignore this at our peril, not to mention the expense of future generations and countless non-human species. Driven by misinformation and disinformation, however, there are still many who think climate change is a hoax, or that it's overblown, or that it's just part of a natural cycle of heating and cooling, and that humans are far too piddling to actually affect the entire planet. And even those who accept the science and understand it, even for them, apathy, inertia, sometimes a sense of futility, and a range of cognitive frailties have made climate change a very difficult thing to grapple with. So happy Sunday, everybody. As Tombstone the Dead Man put it in his last album, welcome to the sixth extinction. All right, hopefully we're not quite at that point yet. Today we have a pair of exceptionally motivated and well-informed guests who are doing their best to help us understand the complexities of climate change and chart a wiser course forward. So I want you to welcome Dr. Gavin Schmidt. Dr. Schmidt is a climate modeler, the co-founder of realclimate.org, and the director of NASA Goddard Institute for Space Studies. He was contributing author for the fourth assessment report of the Intergovernmental Panel on Climate Change, on the work of the IPCC being recognized in the joint award of the Nobel Peace Prize in 2007. Dr. Schmidt was also included in Scientific America's top 50 research leaders and was Earth Sky Science's 2011 Communicator of the Year. Also author of Climate Change, Picturing the Science. The second guest is a pioneer of literary hop, or lit hop, named Baba Brinkman. Baba is a rapper born in Canada, now living in New York, who's traveled the world opening minds with meter and rhyme, making rational thought dope, sticky, and emotionally resonant through his meticulously wrought lyrics. In addition to personally planting over 1 million trees, Baba has recently completed a 6-month off-Broadway run of Rap Guide to Climate Chaos. That was the music that you were hearing before we got started. He composed this with the help of experts such as Gavin Schmidt, and through this he seeks to do nothing less than save humanity from its egocentrism and short-sightedness. So in 2 days, if we collectively decide to vote in somebody who's labeled climate change as a Chinese hoax, it will not be for lack of effort on these people's part. So I think we're going to start. Gavin, are you going to sort of start us through your presentation? And Baba, if you have some insights and you want to chime in, feel free to do so. And at some point, I've got some questions for both of you. So Gavin, why don't you take it away?
I'm going to try and tell a story about the climate, and one of the reasons that we haven't been able to tell this story very well, and what that means, and how we really need to be thinking about this as a topic and as an ongoing conversation. Are we ready to go? Oh. Okay, great. So I'm going to try and throw in a little bit of philosophy as well, because I know that you guys think about the underlying fundamentals of how we're supposed to think about our lives here. So I'll throw in a few little nuggets about science and philosophy as well. So this is how stories are supposed to start, right? Once upon a time, there's some idealistic ideal, and people are wandering around, and then there's a beginning, and then there's a middle, and then there's an end. The problem with the climate story is that we've come in the middle. Right? This is a picture of my boss, my ex-boss, not anymore, but back in 1988, he was the first person to really say very clearly in front of the American public that global warming was here. But in 1998, right, this is where we've seen, and now you can see this is the temperature. You don't need to worry too much about how big these variations are, but the idea is that every year it goes up and down a bit. because of the weather, because of El Niños. But since 1988, we've actually warmed quite a lot. 1988 was the warmest year on record up until that point. And 2015 was also the warmest year on record. And now, if you actually count back, 1988 isn't even in the top 20. Right? So that's pretty remarkable. But the problem is that this is the middle of the story. This is not the beginning. Right? So we know we have much more history that goes back. The graph now goes back to the middle of the 19th century, and we can make other estimates to go back even further. And the exceptional nature of what's happening in the 20th and 21st centuries becomes ever clearer when you look on longer and longer timescales. What we are doing now is of geological importance. But I totally understand that when people look at graphs like this, it's hard to see the wood for the trees. What are we supposed to be focusing on? What are we supposed to be getting out of it? It's a lot easier, in fact, to just show people how the planet has changed. This is a photograph taken in Alaska in 1894 at the base of the Mendenhall Glacier. Some of you may have visited that. And as you can see, you know, it's a pretty windswept environment. You can see the mountains there. You can see the ice right in front of it. Now you can go back to that exact same spot today, and you can repeat that photo. And you can see dramatically that the situation has changed, and it's not just because it's now in color. Right? The glacier has retreated many kilometers, and if you go pretty much anywhere where there's ice, now this is Alaska, but you could go to the Canadian Rockies, the American Rockies, you can go to the Andes, you can go to mountains in Africa, you can go to the Alps, the Himalayas, mountains in Papua New Guinea that used to have glaciers and no longer do. All of these places you can go and you can see how much the planet has changed. You can go to villages also in Alaska where, you know, villages were built on permafrost. But as the permafrost has melted, as the ice has retreated, as erosion rates have increased, this whole village and this house that you're seeing here has actually fallen into the sea, and the residents have voted to move off this island and find a new home somewhere else. Things are happening. Things are changing, and you don't need a graph to see that those changes are occurring. How do we put it all together? This is a picture of an old climate model. Some of you might recognize this as a punch card. This is one line of Fortran code, part of a subroutine that calculated how radiation transfers through the atmosphere. We don't still use punch cards, you'll be pleased to know, but we still use Fortran, we still use computer models, and they're our number one tool for really taking the data that we can see and putting it into a form that we can understand, and not only understand, but attribute, you know, say why things are happening, produce a causal relationship. So, quick philosophical digression. People often talk about complex simulation, so the ability of computers now to put everything together and produce emergent features of the climate system that aren't predictable just from the small scale processes you put together. And people are talking about this as a third pillar for doing science. The other two pillars are, of course, theory and experiment. But the climate models aren't purely theory, but they're not experiments on the real world either. And so people have started to think about this as a third pillar of science. And it's a very interesting way of thinking about what we're doing. And I'll try and get back to this when I get a little bit towards the end. So let's think about the challenge that we have in trying to model the climate. Right? You need to be incorporating details as small as a micron, a particle that might give rise to a cloud droplet, say. And you need to have scales that encompass the size of the whole planet, right? So in meters, that goes from 10 to the minus 6 to 10 to the 8 meters. That's 14 orders of magnitude that you're trying to cover in space. And that's a real challenge. And in time as well, you go from things that are happening in milliseconds to impacts that are going to last for millennia. And again, that's about 14 orders of magnitude. This is an enormous range of physics and of quantities and of data that we're only scratching the surface at. So if you put it in a grid, this is a bit of a weird way of looking at it. You can think about what we can do well and what we have to kind of guess at. So the resolved physics is what we do well. So these are the things that, we can understand everything that's going on. We can solve the equations pretty much as they're written. And weather models take up, the scales from the globe to, a few tens of kilometers, and then make predictions for, a few weeks at a time, right? So they cover that amount of space. Climate models, you can't go as detailed, but you have to go longer. So you take up a slightly different set of the space. So the climate models in the 1990s took up a very small section here. In the more recent times, we're doing better. Computers have got faster. We're now incorporating more detail, and we can go, to longer timescales. But there's still all of the stuff that's too fast or too small to do properly. These things have to be incorporated, but we don't know exactly what's going on. These are the things like the formation of individual clouds, the response to very small scale topography like a hill or a mountain or something like that. If we work out how long it would take us to have an estimate of everything that's going on from first principles, we can kind of work it out from how fast we're going. We're doing about 1 order of magnitude every 10 years or so. So we've got another 8 orders of magnitude to go before we're doing it properly, if you like. And so we'd have to wait till about 2100 before we were able to work out what's going to happen to the climate in 2100. So that's a little unfortunate. So we're trying to do better. We're trying to see if we can work out things even though we know that these models are incomplete. So what we do is we try and break it down into processes. So the processes involved with sea ice in the Arctic, the processes involved with cloud formation, with the sunlight going through the atmosphere and being absorbed and reflected and re-radiated. We're trying to put all these things into positions, and by putting each bit into place, we end up with something that starts to resemble the real world, but we know that it's incomplete. We know that we haven't included everything, but we still have a good enough view that we can recognize what we're trying to model. It's very important that people recognize that all models are wrong, right? None of them are as complicated as the real world. All of them are incomplete. Some of them have bugs in them. Some of them are just conceptually wrong. And yet, despite the fact that all models are wrong, and this goes for weather models and climate models and quantum physics and special relativity and all those other kinds of models, what we're trying to do is we're trying to see whether they're useful. Now, it's easy to see with complex simulations that the models must be wrong, because if you go down into the details, you can see that they disagree with observations. But in fact, all models are wrong, and it's well worth thinking about that whenever you look at any kind of scientific prediction. So, what does a climate model look like? So it looks a little bit like this. This is an animation showing all of the different particles in the atmosphere. So the orange is dust that's coming off the Sahara Desert. The white wisps is sulfur dioxide pollution coming from burning coal. You can see the blue, that's sea salt being whipped up by the winds in the ocean, put into the air. The green you can see is coming from forests and from biomass burning, and each of those red dots that you can see, that's a fire somewhere on the world, and you can see that the fires are producing a lot of the green smoke, and then you're seeing a lot of the white pollution coming from China, from Borneo, from the industrialized parts of Australia. You can see that the model produces tropical cyclones. You can see a couple hitting Japan and veering off right there. These are emergent properties. The model isn't told that it has to make a hurricane at this particular time. It does that because of how the physics interacts. You can see the winds going around Antarctica, spinning up the storms that you can see by the signature that they have in blue. And what you're seeing here is that climate and the weather affecting these particles at all scales. But of course, these particles themselves affect the climate, right? So they're part of the natural variability of the system. And of course, there are other natural forcings. So you can see a volcano that just went off near Madagascar, right? Putting sulfur dioxide, natural sulfur dioxide into the atmosphere. But it's small, so it dissipates quickly. These kinds of models allow us to ask really, really complex questions of the system and actually give us skillful answers. So what do I mean by that? Skill. A model is skillful if it gives better predictions than a simple alternative. So if you think about weather models are skillful. They're better than what you can do just by looking out of the window, or predicting what's going to happen is going to be the same as what happened today. Weather models are actually pretty good out to 3 or 5 days, and they're getting better at 7 or 10 day forecasts as well, and they're demonstrably useful. So the question that we have to ask is whether climate models can be demonstrably useful. And I think they can. So this is a comparison of model simulations for the 20th century compared with observations of the same time period. So what you're seeing in the early years is a lot of up and down, a lot of blue and yellow. All of that is weather, right? It's part of the natural uncertainty, chaos, dynamism in the weather system itself. But as you're getting towards the 1990s and the early 2000s, what you're seeing is a new pattern that's emerging. You're seeing a pattern that is actually the fingerprint of global warming. And we can demonstrate, though I haven't really got time to do it here, that this pattern is a very clear fingerprint of the increases in greenhouse gases, and particularly carbon dioxide. So, but models aren't perfect. You saw that the model was roughly right in many respects, but not perfect at all scales. But it's important to know that this can have multiple causes, right? So models can be wrong, we've already addressed that, but data is also imperfect, and how we compare models to data is also a challenge. Oftentimes our ability to see something or observe something is restricted because of where we have instruments, what kind of instruments they are, and we need to build that into our comparisons before we can really attribute why anything differs. But here's why we need to have models. If we had observations of the future, we obviously would trust them more than models. But unfortunately, observations of the future are not available at this time. This is the key. We need to have a model to make predictions. And we need to demonstrate that the models are credible in making those predictions. But we're in a situation where what's going to happen is now a function of our choices as a society, as a community, and as individuals. We are in a position where we are able to choose our own climate adventure. So here are a couple of different scenarios that we could think about. Aggressive mitigation is, if we started 10 years ago and we went really, really serious to reducing emissions. Business as usual is if we make no effort whatsoever to curb emissions and we burn all the hydrocarbons that we can find. And serious mitigation is perhaps something in the middle that is conceivable that we might get around to doing. As you can see, the difference between the aggressive mitigation case and the business as usual is that one is bright red. Now, I chose the color scale here, so that's a bit of a cheat, but let me just be clear about how big a change this is. The bright reds here are 4 degrees warmer than the end of the 20th century. Now, how big is that? What does that mean? If you go back to the last ice age, which was 20,000 years ago, you had ice sheets that covered almost all of North America down to the level of New York or Ohio. The sea level was 120 meters, 400 feet lower than it is now because of all that ice. And the great forests, the great boreal forest didn't exist, and the Amazon was a savanna. It was a very, very different planet. The total cooling associated with that was only about 5 degrees Celsius. So that's 9 degrees Fahrenheit. Where we're expecting to go, if we don't do anything to change our trajectory, is another 5 degrees in the other direction. So 1 ice age unit towards the warm side compared to the cold side. That too will be a different planet. So I think my final philosophical digression, the use of complex simulation is really something very new, but it's not really different from theory and experiment. It's just it blends the two. We can experiment on these computer simulations in the same way that we can experiment on a model system in a laboratory. And we can change the theory, we can improve the theory, we can make it better, and we're always testing it. So complex simulation really just is something that lies in between the two pillars that used to exist in science and philosophy. I find that a little fascinating, but I'll move on now. I'm contractually obliged to include a picture of a polar bear in every talk I give. And this is one I took in Churchill, Manitoba. That's not love in its eyes; it's hunger. It's not been hunting for about 4 months at this point, and was just eyeing me up for lunch. We spend a lot of time thinking about megafauna and how they might be impacted by potential changes in the climate. But we really need to think about other kinds of creatures, and perhaps ones that aren't so photogenic. These guys, for instance. Some of you might know what they are. They're the larvae and early stages of mountain pine bark beetles. These are temperature sensitive, so they breed far more readily when the winters do not get cold. And the winters have not been getting cold. And so any of you who've been out west, the Rockies, all the way up to British Columbia, will have seen huge swaths of pine forests totally devastated, totally brown, because of these little creatures. These were not easy to predict, right? The response of ecosystems to climate changes is still very much at the frontier of what we know as scientists. And this came as a surprise. And so we expect that there are going to be other surprises because we don't know as much about ecosystems as we know about the climate system itself. This is the impact that they have on an otherwise green forest. They will totally devastate the pine stands. So we're in a position, scientists like myself, And it's not a unique position. And Sherwood Rowland, who won the Nobel Prize for his discovery of the chemistry of the ozone layer and ozone depletion, he described it thus: "What's the use of having developed a science well enough to make predictions if, in the end, all we're willing to do is stand around and wait for them to come true?" And this is something I think about a lot. You know, we do have these predictions for what's going to happen. And as a scientist, you might think, I'd be happy to have our predictions come true, because that would demonstrate how clever we all are. But we really don't want our predictions to come true, because we're not just scientists, but we are also citizens and parents and children and members of a community. And we want our community, our families, our societies to do better than they did in the past. And so we're in a position where it's not sufficient to just stand around and wait for science predictions to come true. We have to stand up and say something and tell people about what we found and encourage people to make better decisions. And so with that, thank you very much for listening.
All right, thank you very much, Dr. Schmidt. I want to ask you one question before jumping over to Baba, and that has to do, can you talk about how your feelings about scientists being advocates has changed over the years?
Yes, it has changed over the years. You know, I think you start off as a scientist thinking that advocacy is something for other people. But I've come to learn that in being a scientist that talks in public or that has a public profile, you're inevitably advocating for something, whether it's better education, science literacy, funding, or political action. You're advocating for something, and you're better off understanding what you're doing than just kind of stepping out and not really knowing what you're doing.
All right. So now we're going to jump over to Baba for a while. Gavin, if you have anything that you would like to add, always feel free to chime in.
Sure.
Baba, before we dive into Rap Guide for Climate Chaos, can you share a little bit about your background, your education, how you came to be a peer-reviewed rapper and troubadour for critical thinking?
Sure. So for those in the audience who aren't familiar with me, I guess I'm one of those other people that Gavin was just talking about who've become advocates for taking the science seriously and doing something about it. Agitators. But I didn't start out with science as my subject. I actually did a master's in comparative literature and studied the Canterbury Tales, which I wrote into a rap show that I toured in England for several years. And I was kind of a medieval literature rapper. But at one point I was approached by some scientists who said, "You're good at explaining the Canterbury Tales with rap. Could you explain," well, the first challenge was Darwin and the theory of evolution, and that turned into a series of theater shows, rap theater shows, and albums that explained or explored scientific subjects. And I thought climate was one of the most important ones to tackle because of everything that Gavin just said, because it is an existential threat to a lot of life on Earth, both human and other forms, and there's this odd disconnect where people, even people who know this, go about their lives and continue doing the things that they do and emitting CO2 that they do via their driving and flying and their careers. And I thought there was an interesting psychological dimension to this challenge of, okay, we understand it's happening, now what should we do? Both at the level of individuals and at the level of whole societies. So I created this show, Rap Guide to Climate Chaos, in order to try to bring some of those questions to the forefront. Once we've accepted that it's happening, what really should we do about it? And is there merit in reducing our footprint via taking shorter showers or giving up meat in our diets, or cycling instead of driving? Or do we need to do this, do it at the societal level of institutions and government intervention, pricing carbon, mechanisms like that? So, you know, that's something I find that speaking to scientists, I've found that they differed on the degree that they think those different kinds of responses are important. I tend to lean more towards the institution and regulation and carbon pricing side, but I wanted to open that conversation up to the audience.
Now I want to walk through some of your songs. We'll get to some of that as we move through the songs. Your first one on there is options. You've got the lyric, get your head nodding, solving some problems, we've still got options. So I want you to talk about three things. One, how, the importance of using art forms to make people aware, to help them understand, and then also, most importantly, to get them emotionally invested. There's a lot of people that won't sit down and read a book on climate change that might see your stuff, or that they do read a book on climate change, but they're still not impacted to really change their lives.
Sure. I don't want to disparage scientists in any way. Gavin, he's a very engaging lecturer. I could listen to him talk about climate all day long, but I also feel like people are galvanized by having an emotional connection and an emotional response. And there is something about music and the arts and theater and entertainment that its whole raison d'etre is around evoking an emotional response. So in my show, my goal was to try not just tell people about the science and the stakes, but also make them feel it, like maybe someone's feeling terrified by the scale of what could happen, make them feel inspired, or even elated by the possibilities of assembling a huge group of people that are ready to tackle this and do the necessary work, and also feel outraged, feel a deep and visceral revulsion at the degree to which a lot of this stuff has been delayed unnecessarily by vested interests. A lot of fossil fuel companies financing right-wing think tanks, their entire goal is to distort the science and make people feel like it's more controversial than it really is, and sort of teach the controversy, which is entirely this cynical attempt to protect the market share of some entrenched industries that are driving the source of this problem that we're talking about here. So I think the appropriate response to that is outrage and indignation.
Can I jump in for a second? And Gavin, I'd invite you on this one also. Do you think the same way you're not allowed to yell fire in a crowded theater, for these groups, Heartland Institute, Cato Institute, all the right-wing think tanks that are purposely dumping out misinformation and harming society, do you think there's a legal case that can be made against them? Is there legislation we should take to make it illegal and make them accountable for putting out the information that's harming all of us?
That's a tricky one. I mean, I'm a supporter of the First Amendment, so I don't think it should necessarily be illegal to be a climate denier, but I think it should be illegal to fund climate denial in secret. There are these sort of short shadow funds that can be donated to by anonymous donors that can then in turn turn around and put huge resources by campaigns to misinform, and no one knows where the money comes from, though it's kind of obvious when you follow the breadcrumbs. And then sometimes you'll get lucky and an internal memo will turn up. So there's a legal case being prosecuted right now in several states against Exxon, which is a company that internally had scientific documents and research showing that they were fully aware of what we're talking about, even in the 80s and 70s, and yet their outward public stance has always been, we don't need to do anything about this, it's not a big problem, move on, which is, that's pure hypocrisy. And I think the legal case in that example actually comes down to securities fraud, because they're portraying their market position as one that's more stable than it really is, based on what's going to be needed to be done politically and in terms of regulation to deal with the climate problem. Basically, the market share is based on ignoring climate change and taking us to the worst case scenario graph that Gavin showed us. But most of us in society probably aren't going to stand for that scenario, which means their market share is way worse than what they're claiming, and the people who are investing in their companies are actually being defrauded.
Yeah, and I guess those investigations can't just be a tiny little slap on the wrist where it's just a cost of doing business is you cheat, you get caught, you pay your little fine, and you're still raking in hundreds of billions.
Can we get Gavin to come in on this question? Because I know he's had some firsthand encounters with let's say, the denial industry. So what do you think, Gavin? Should there be any kind of regulation on, or is there a free speech line to be drawn around climate denial with the public safety argument?
Yeah, I have to say no. I mean, I think it's one of the fundamental things about a democratic society is that people should be allowed to say whatever they want. But people need to say these things transparently. When something purports to be, the voice of the people, or Mrs. Smith from Peoria, but really it comes straight from Hay Street. People should be able to see who's paying for that, who these people really are. I think greater transparency is one way to deal with the amount of nonsense, and I think better journalism. I mean, I think that this is something that we can campaign for, and we can be very clear about it. That journalists have a responsibility to truth as well as just reporting what people say. And I think if more journalists took that seriously, and if the media as a whole took that more seriously, we'd not be quite in this position.
So Gavin, you had that great quote about what good is science if all we do is sit by and watch the predictions come true. And Baba, jump in on this also. You speak about this in one of your songs. Cognitively, we're not, evolutionarily, we're not set up to deal with a problem like climate change, right? We don't see the immediate threat. It's distributed, to lots of people. So given what we recognize about how humans react to an immediate threat or one that's dispersed elsewhere or shared by many other people, do we need to change our approach? And, if we have propaganda mills that have hundreds of millions or billions to spend, can't that overwhelm scientists like yourself, and artists like Baba trying to get the word out? So, do we need to use our understanding of rhetoric and how people process stuff and craft a different message?
So we do, but I think most of all what we need is political leadership. We need, people, because there's always going to be vested interests. There's always going to be people who don't want something to change for their own selfish reasons. And that's true for every topic. So how do we get past that in topics that aren't quite so contentious? It takes leadership. It takes courage. And unfortunately, that's been singularly lacking in some parts of the US political spectrum, but is available in spades in Europe or in other parts of the world or in different topics. So I think climate is a unique thing, but it's not. But it's the reasons why it's unique is not because people don't want to hear about it. There's lots of other topics that people don't want to hear about. It's not because there's industry money that's putting out propaganda. They put out propaganda on all sorts of things. But what's been lacking is real political leadership, and I think that is something where individuals, communities can make a difference, because they can prompt their political leaders or create their own political leaders who do have that courage to deal with reality and not fantasy.
Baba, anything you want to add?
Yeah, I think there is an evolutionary dynamic going on here. You pointed that out, and I talk about it in my lyrics a bit. I think there's something about climate that makes it a particularly sticky problem, and I think you kind of hit on it with the distribution of responsibility. I think people don't want to feel like they're individually culpable for it, but this research just came out that we can each, or Americans anyway, can each take credit for the melting of a small apartment slice area of ice every single year based on their individual emissions. So there's something about driving the message home that we are responsible for the situation that we're in rather than scapegoating. I think political leadership is going to be part of that, because brave politicians can speak truth to power in these kinds of situations. But I think regular citizens as well have probably been a little shy about talking about this subject. One of the things that I advocate for is making this more central to the public conversation, and to just talk about it and get educated and tell your friends about it. And I think politicians who have shied away from this subject partially do so because they see it as politically disadvantageous to them. They're in survival mode, and they're skipping it because they know the political will doesn't exist. And it's hard for me to fault politicians for making that calculation to save their jobs, because they're kind of right. When it comes down to the polling, I think any Republican that ran on a climate advocacy platform would not even come close to getting nominated, and Trump is the perfect example of that. He's the worst of the climate denialists, and he's the winner of the Republican ticket. So it seems it needs to start at the bottom up level as well, I'd say.
All right. Your second song is actually one of my favorite on the album, IPCC. So I'm not going to do it justice. Wars, famines, drought, floods, hurricanes, heat waves, murders, thugs, chaos, refugees, stress, disease, extinction, disaster, IPCC. So you and your wife are about to have a baby in just a few days. How do individuals go about life when you have the apocalypse waiting, just on the other side? And how do, businesses and countries sort of ignore this and keep going about business as usual?
Well, I think that's one possible future, which I wanted to try to paint as vividly as possible in a song to make people aware of what the stakes are right now. And that's why the first song says we still got options, and the second song says wars, famines, droughts, floods, etc., because that's why it's important to remember we have options. Because I think extreme pessimism can lead to complacency, and extreme optimism can too. So as a science communicator, not a scientist, it was largely for me about what rhetorical strategies will work to connect people. And if you're too optimistic about we're an inventive species, we'll figure it out, people wash their hands of it and go, great, tell me when you fixed it. But if you're too pessimistic, they say we're doomed no matter what, then people say, screw it, I'm just going to live it up in the meantime. So the challenge is to represent the possibilities, the optimistic possibilities, and the horrific scenarios on the downside as poles. And these are poles that you're trying to keep people in between and not get them sucked into either vortex, because you need to kind of be skeptical and hopeful at the same time.
This is another, I'm not sure if you're familiar with this book called The Great Disruption by Paul Gilding. Basically in here, he talks about how depressing it was as somebody who was involved with climate research, that nobody wanted to hear it, and no companies would do anything about it. But then when he took an economic approach to trying to show companies, this is in your long-term interest to start addressing this, he had much better success. And I think it was also his opinion that we are starting to put the infrastructure in place, and that's the key things that we can do right now, is even while there's a lot of people denying it, start building the infrastructure so we can react quickly once we pass a psychological tipping point and decide to address this. Do you guys, is that an accurate assessment, do you think?
I was in Paris to sort of observe the negotiations there a year ago, and I kind of went into that process with a bit more of an anti-business mentality, like corporations are taking us down the toilet with their pollution practices. But I was actually surprised by how vocal the business community was in Paris, calling for regulation and calling for decisive action. It certainly wasn't sort of government and citizens against business at all. And I think the economic case for prosperity via renewable energy does make a strong, optimistic view more viable, but the problem is that it's not happening fast enough. Just like Gavin's point, we have model details clear enough by 2100 to understand 2000? Do we have the technology online to solve the climate problem a little too late to solve the climate problem? We need a financial framework to change the incentive system, because right now, more than anything, it's cheaper than clean energy. That's because it's free to pollute. But when you speak to people, even libertarian people on the right of the political spectrum, about whether it should be free to pollute, they mostly say they think it shouldn't be. The dispute is whether now it's sort of a climate skeptic dispute that drives the Republican rejection of it. They don't think CO2 is a pollutant. So if you can get them to accept that CO2 is a form of pollution with negative externalities, just as bad as dumping acid into the river, then they will support regulation in principle. But that's not why they have to reject the idea of CO2 being a threat, because the logical conclusion of that, even by their principles, is that it has to be dealt with like a pollutant.
I think if we can conclude anything from this year's election season, the notion that people have principles is one that we can probably toss out.
When you get something like people saying, well, CO2 isn't pollution, how much is that, do you think that's genuine misunderstanding, and how much is, that they're just part of the climate denial system and they will say anything, even though they're well aware, it doesn't have to, why it is a pollutant or why it is dangerous to high levels?
I saw a great presentation by Michael Mann recently where he talked about the spectrum of climate denial, from Donald Trump saying it's a huge hoax to people saying yes, it's happening but it's natural and humans have nothing to do with it, to people saying yes, humans caused it but it's pretty minor and we don't have to worry about it, to people saying people caused it and it's not minor and it's going to be a big problem, but even if we tried to fix it, we couldn't do anything about it. And what all these perspectives have in common, they have in common that government has no business playing any role in mitigating climate change. So to me, that looks like the cart before the horse. It looks like the libertarian principle of non-government intervention is what's driving the whole spectrum of denial positions. And it's one thing that can't be accepted is the thing they start with from the beginning, which is why it's such a challenge to get people on board with that.
There's also some people that, I imagine will come on board very late and act like they've been leading from behind the whole time. In terms of greenhouse gases, Bobby, you talk about this. Can you go back and give us a little history? When did we first become aware of some of the science of greenhouse gases? This isn't a surprise that just came up 10 or 20 years ago. When did it start? When did we start to figure it out?
Well, no, people knew about greenhouse gases back in the 19th century. And people first started thinking about what was happening when we started to increase them in the 1890s. That was kind of redone in the 1930s, and then the physics really kind of matured in the 1950s. This is not a new problem. It's not something that people have just made up in the modern era. This is very, very well established physics that goes back more than 100 years.
Bobby, you have a couple songs talking about joules and energy, that we really do need energy to keep our economies going and people's livelihoods that they've already established. So what are other options? Do we have some realistic options that we should be turning to?
Yeah, there's a great website and source for information called the Solutions Project. It's out of Stanford, and some energy economists at Stanford have done a state-by-state analysis for the U.S. and shown how every single state in the U.S. can get to a net zero emission energy economy by 2050, but without economic collapse and without any reliance on Hail Mary technological inventions or innovations to save us. It's actually there. The spectrum, hydro and solar and wind and geothermal and all the various renewables that we have currently is going to be sufficient. It's really just a question of political will and political leadership, and at every level. Of course, who you vote for as president makes a big difference as to which direction the climate response is going to take, but cities have climate policies too, and so do states, and so do corporations. And some corporations are already restructuring their supply line to make it compatible with a zero emission near future. And other corporations are acting like they're going to get away with their current policies indefinitely. And in my estimation, the ones that are cleaning up their process are the ones that are going to be at a massive competitive economic advantage soon, because I don't think people will stand for the current business as usual scenarios. And if government does legislate carbon, which by the way just happened in Canada, Justin Trudeau just announced a carbon tax or price on carbon that's going to come in 2018, escalate every year to get Canada on target with its emissions. This is just like dominoes falling. It's like gay marriage legalizing. It's like lots of things. Pricing carbon is on the march, and the places that do it late will be at a disadvantage compared to the places that do it early.
So, Gavin, do you have any thoughts? If we did have the political will and could sort of rein in our corporations, how quickly could we have suitable green energy sources to really take off the burden and slow climate change? Like, are we technologically within 5 or 10 years of being in a much better position if we had the political will, or do we still have a lot that we need to develop?
I think there's certainly potential to do much better than we're doing. And sometimes it's not the obvious things. Having better connected grids across the country would go a long way to helping balance the loads between wind power in Texas and North Dakota and demand on the east and west coasts. We can be certainly investing a lot more in offshore wind, solar panels, and the like, and even nuclear power. I think has a role, at least in this country, for improving the situation. A lot of the coal power plants are being pushed out of business. Not really because of climate change, but because of the competition from natural gas, which is slightly better for the climate than coal, but is still not good. And so we have a long way to go. But we're making investments now for 30, 40, 50 years. I think we can be making smarter investments right now.
And just if people do need a quick shot of optimism, it is the case that the cost of installed solar has gone down 80% in the past 5 years. So solar technology appears to be on something like a Moore's Law curve, where it's getting better and better really fast, and the economics of that are great. But because the more we invest in that, the more capacity will advance, and the cheaper it will be to install, and that will continue the process that Gavin just mentioned, where if coal is under threat by shale gas and natural gas, having more and more solar installed is going to just make coal even less economically viable. Trump can promise coal miners their jobs back all he wants, but he doesn't have control of the entire economy and all the forces that are leading us in that direction.
So where do you guys recommend people go to get reliable information? Because you'll get very diametrically opposed views on a question like that, depending where you look. So where are some reliable sources of information? And maybe you can even comment more generally on, the United States has been through this anti-intellectual phase where we don't really respect expertise anymore. And, is that something that affects you? Like, Gavin, when you speak, or if you speak to a conservative group, are they still challenging you when they don't have sort of a basis to challenge, or do they sort of accept the science, when you speak?
So let me just make it clear that there isn't like one-stop shop for all people at all levels of knowledge or with all levels of time available to just go. I mean, if you do have time and you're interested in the science, You can go to the National Academies reports, you can go to the IPCC, but that's pretty dense. Some of the groups that are doing a good job at passing it down and making it a little bit more comprehensible, places like Climate Central, which is a news organization which focuses on climate change. Climate Nexus does a pretty good job journalistically as well. But if you want to dive in and look at the data yourself, then go to places like NASA and NOAA. All the data sets that we talk about are downloadable. You can play with them. Some of them you can play with really very easily. So, depending on your level of interest, there are different places to go. The worst place to go, of course, is TV. And most of the mainstream media. The Times does a pretty good job, but there's not enough context for most of that. And on TV, it's dealt with appallingly. So, if you're independently minded, check out the NASA pages, climate.nasa.gov. NOAA has something very similar. Those are good places to start looking at the real data.
And I'm just going to give a plug for a website I just found out about a few weeks ago called Climate Feedback, where they've assembled a group of climate scientists to do quick reviews of mainstream media articles. So you can go there and you'll see not just an article from the Washington Post or the Times or the Wall Street Journal. You'll see a commentary from a climate scientist who read it and pointed out where they may have diverged from scientific literature and point you towards sources that can correct. So it's a nice dialogue between journalism and science.
And Bob, I just find it kind of inspiring. Can you share what your process was for educating yourself on climate change before doing your rap guide?
Sure. So when I decided to do a show about it and an album about it, it was first just a 6-month research process, which included a number of books, Storms of My Grandchildren by Jim Hansen, who used to be Gavin's boss there at NASA, and Merchants of Doubt, I highly recommend, for the climate denial industry history. There was a real fascinating one called Don't Even Think About It by George Marshall, based in the UK, which is about the sort of the psychology of not climate denial, but just ignoring the problem and how you get past people's filters. Climate Casino was one that I read as well. And then there's a lot of stuff online from some of the sources Gavin mentioned: Climate Central, Climate Nexus. Skeptical Science is a great website that takes basically every climate denialist argument and just debunks them one by one. Like anything you've heard a climate skeptic say in a debate with you or on TV or anywhere, you can type in the buzzwords they use and just watch them take it apart. And once I had that, sort of a draft of my show, then I reached out to several scientists, including Gavin, and sent them my script and said, could you come back and let me know if I've sort of misrepresented the science in any way, which for me is important because I wanted to make sure that I'm communicating accurately, but also I have this brand that I call peer-reviewed rap, and it does give me a certain kind of swagger, let's say, to be able to stand on stage and say, yeah, I'm rapping the army of scientists, don't shoot the messenger, and sort of be a spokesperson for scientific orthodoxy. In a way, it doesn't sound very rebellious to be a soldier for orthodoxy, but in today's world, it's the orthodox view that needs defending.
Another of my favorite songs of yours was What's the Beef? And you talk about how if you have 97% of climate scientists in agreement, and yet the contrarian view is getting equal time on the media, that really is a problem. How do you think we address this? And Gavin, again, feel free to jump in. Does the scientific community need to get its own, like independent media, or start educating reporters so that they're scientifically literate? A regular person that just turns on TV is very likely to see two people saying exactly opposite things, and they don't necessarily have the capacity to fact check it.
We think that TV is there to educate us, but people that run TV stations know that it's just there to entertain us. And so the only way you can break into that is to be entertaining. and whether that is taking a very controversial position, which is entertaining in some way, or like rapping or doing a show or something. That's another way to get attention. I hope we're going to get to see some of your work, Baba. Like, it's all very good to hear about somebody talking about music and reaching people's emotions, but it's a lot more fun to see it.
Yeah, well, maybe you can play a YouTube video or something. But I could do a rap, but I have a feeling that the sound might be a little washed out. But if you think it'll play in the room, I'd be happy to drop a lyric. It'll play? All right. So why don't I do some... I'll do a verse or two from my song IPCC. That was one extra C, actually. Okay. It goes like this. Hollywood summer blockbusters can't touch this. I get my thrills from the latest reports published by the Intergovernmental Panel on Climate Change, formed in 1988 to get the science straight. Now they dropped the fifth assessment and the data's up to date. So allow me to summarize. Bad things on the way. Higher emissions, sea level rise. Dire predictions on target for disaster movie style predicaments. In Copenhagen we set a limit of 2 degrees, but that's still enough to disintegrate major ice sheets over the course of centuries or maybe decades. Yes, some of the details are still up for debate. They fluctuate between certain disaster and likely disaster, slow and steady or higher and faster. Consensus, it's the lowest common denominator, which means it's probably gonna be way worse than the wars, famines, droughts, floods, hurricanes, heat waves, murders, thugs, chaos, refugees, stress, disease, extinction, disaster, IPCC.
So I think you just made me look bad by doing the original performance. All right.
Rob, to speak to your question from a moment ago, I think the problem with TV communicating climate over the years is that they feel like they have this we have to be entertaining mandate, that putting two people in a dialogue or a debate serves better than just having a talking head. So, okay, that's what the industry demands maybe, but their debate doesn't have to be between a science supporter and a science denier. The debate could be between someone who accepts the science and thinks strong EPA regulations are the way to deal with it, and someone who accepts the science and thinks a more market-oriented solution like a carbon tax or a cap and trade system is the way to deal with it. And that would actually be a legitimate debate to have. That would still be a reality-based, fact-based debate. So I think they've just tilted a bit too far, or way too far, in the direction of representing both sides of the story when they know full well that one of the sides is based on scientific evidence and the other side is based on ignoring scientific evidence. That's not the only way to have a debate.
So we're probably going to want to wind down over the next, 15 minutes. If there's anybody that has questions, just raise your hand so I know. Can you guys talk about, is there any technology on the horizon that looks like it may significantly help reduce climate change? And do we have good ways to test that before just releasing the experiment on the world in case it goes bad?
No. No, I mean, the things that are going to make a difference are things that we already all know about.
So like the idea of releasing particles into the atmosphere to reflection of light, that's not anywhere close and has too many potential enormous downsides.
Well, the reasons why that won't happen have got nothing to do with the science and everything to do with geopolitics. No Western democracy would do it, and the dangers of having a rogue state do it, or some regional consortium do it, is so large as to basically make it a non-starter.
And rogue states don't tend to participate in the international community from the perspective of being good global citizens, which is that would realistically be the only motive for doing something like that, however misguided it would be. But I think some of the stuff that people do know about may not be associated in their minds with climate. So the thing that just came to mind when you asked that is self-driving cars. Now, we know self-driving cars are coming soon, and we often think about it in the context of, wouldn't that be weird and freaky? But it could actually completely change the transportation infrastructure and make car ownership something that's much more communal. You can buy a car and you're not driving it 90% of the time, but what if it was driving itself around the neighborhood, giving people taxi rides? That could really change how much, especially if it was an electric self-driving car. We may only be a few years away from having that option where you buy a car and it uses its self-driving technology to ferry people around and you earn money. And that actually, that kind of thing could change the calculation of emissions quite a lot in some domains that we don't even think about. Gavin mentioned smart grids, the Internet of Things, all the power wasted by our appliances, things like that. So I'm sort of excited by some of these applications, but I don't think we should just sit back and wait for them to happen. I think taking the issues seriously and making sure the price of carbon is not only fair, but it's also going to spark the kind of innovations that we can't see right now, because they're on the far side of the event horizon. That will be the other side of the positive coin of carbon pricing.
Do you guys have any feelings on the Paris Accord? How useful was that, or would it be? How important is it that the U.S. re-engages? And do you believe is it useful to take incremental steps like that? And are there any parallels or lessons to learn from things like the Montreal Protocol?
I didn't really catch the question, I'm sorry.
It was about the Paris Accord and how important it is.
So the Paris Accord is important because it demonstrates that 195 countries can in fact agree that this is a problem and make their own steps towards moving forward. The pledges that people have made, or the countries have made, don't add up to a sufficient amount of effort compared to the size of the problem. But it's a process, and every few years, people, I think, will find that it's actually been easier to do things than they thought, and it will be cheaper, and then they'll be able to use, the best practice from other countries to make better and larger pledges in the future. So I see that as a step in the right direction, but it is, in fact, only a step, and there's many more miles to go.
Yeah, my take on the Paris Agreement is that the amount of greenhouse gas emissions it's set to achieve is clearly not enough, but it's significant. The reason it's worth celebrating is that it overcame the main obstacle to a global climate accord that's been stopping us for so long, which is the rift between the developed and the developing world. With the developed world saying the developing world is going to be where the majority of emissions growth is coming from, so you have to do something about it. And the developing world saying, well, the majority of CO2 in the atmosphere now is caused by your industrialization process, and how can you tell us not to try to catch up now? I think Paris did a great job of bridging that gap and making there be accountability so that developed nations are paying more for the cost in accordance with the fact that they've caused more of the problem. It allows for growth and development. It doesn't put poverty alleviation to the backseat of climate action, and it sort of got all these mechanisms transferring technology and opening up patents so that developing countries can get access to more renewable energy infrastructure faster. And that's the kind of stuff that it's technocratic and in the details, but that's the reason the previous accords fell apart and led nowhere. And Paris pretty much fixed that, and now it's just about the scale of ambition of the various commitments, which is also a big thing that needs to be dealt with, but at least it doesn't have a poison pill in it anymore.
All right. Are there any kind of parting thoughts or things that you would like just the general person that's interested in climate change, things that we should have, we should look into a little bit more, learn more about, any kind of new scientific thoughts that are emerging, anything about the disintegrating ice sheets, any things, take-home message that we should, if we're interested, go spend a couple of hours over the next week learning more about?
encompasses so many different things. If you're interested in ice sheets, you're interested in polar bears, you're interested in insect outbreaks, you're interested in dengue fever, if you're interested in sea level rise, if you're interested in agriculture, there's different places to go for all of those things. I find that, I can't actually be interested in every single thing. So I follow my nose. And, things that interest me, I kind of dive in and look at the details of how and why people think climate will impact that, and and kind of go from there. One of the things I learned quite early on in talking to the public is you can't tell people what to be interested in. They have to be intrigued by what you're saying, or they have to follow their own instincts on a path to knowledge on this.
I would recommend a newsletter called The Daily Climate, which aggregates news stories across all different platforms, gives you a sort of daily email blast that you can click on as a palette. It's sort of a quick and dirty way to keep track of new developments.
And this is the last question. Is there anything that we can do to sort of help you guys in your individual pursuits? Is there anything that we can do to make your job at Goddard Institute easier? And Bob, how can people find out more about your work and support what you do?
Yeah, well, I think you guys heard one distorted rap verse over the course of this session, but the Rap Guide to Climate Chaos is an album. It's like 24 songs about the whole range of, from the science to the politics to the economics. So it's on iTunes if people have Apple Music. It's on Google Play. You can mail order the CD if you still do physical CDs, although they're much worse for the climate than digital downloads. And my website is bababrinkman.com, and you can click through to the album there.
All right, well, thank you very much for working through the technical difficulties. We appreciate it, and have a great afternoon. Thank you.